Unit 1, Level 1, Topic number 2. This will cover the essential question, how can we model integers on the number line? We're learning about this because modeling integers on the number line helps us solve real-world problems. Later on, you'll see how it also helps us visualize more difficult and challenging problems where we're adding, subtracting, and multiplying integers. So make sure you're following along on your notes and writing things down as we go. You'll see on your notes, the first thing we're going to review is integers. Now, in the first topic in this lesson, you did some flashcards and online, and you talked about or you looked at the definition of integer. So think about what an integer is, and here's some examples. Some of these numbers are integers and some are not. So think about what you know about the definition and how would you categorize these? Which of these numbers are integers and which are not? Well, here it is. The definition of integers is the whole numbers and their opposites. So here are the whole numbers, right? Here's 0, and then 1, 2, 3, right? These are the whole numbers. And the opposite of a whole number, since they're positive, the opposite of a whole number is a negative number. So here's 1, the whole number, and here's its opposite, negative 1. And here's the whole number 2, and its opposite, negative 2. And here's 3, and its opposite, negative 3, and so on. So you get the idea. These are the integers. So based on our group of integers here, here's how we would sort them. And please make sure that you write this down on your notes. The examples that are not integers from our list were 1/2, 33 hundredths, and 8 tenths. These are not whole numbers or their opposites. Now on the other side here, we have 5 examples of numbers that are integers. 59, 3, and 33 are whole numbers. Negative 25 is an opposite of a whole number, and negative 33 is the opposite of 33. So all of these numbers, the whole numbers and their opposites, are considered integers. So how do we place integers on the number line? Usually, here's an example, right? 0 goes sometimes in the middle, sometimes not if we don't need it to be in the middle. But for our purposes, usually 0 will go somewhere in the middle. And then to the right are the increasing, this is the increasing direction, the positive direction. So the farther you go to the right, the more the numbers increase. And you can see here are the whole numbers. Here's 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And then the opposites are in the decreasing direction to the left. So the farther you go to the left, the more the numbers decrease. We call this going in the negative direction. So here's 0, and then negative 1, negative 2, negative 3, negative 4, and so on. So this is your basic standard number line. Nothing skipped, no numbers skipped, it's just the basics. Positives to the right, negatives to the left. But my question to you is, are there different ways to place numbers on the number line? Are there things that I can change to make it more useful to me? And the answer is yes. There are some things you can change. There are some you should not change. So here's some examples, and these are on your notes. Let's start with the one that we looked at just a moment ago, your standard number line. And this one starts zeros in the middle. The positive numbers are to the right, and the negative numbers are decreasing to the left. And if you see these other examples down here, you see that they are skipping by different numbers. So here we're not skipping any numbers at all. We're going 1, 2, 3, 4, 5, and so on. And here, negative 1, negative 2, and negative 3, nothing is being skipped. So if I were to ask you, what is the length of each space on the number line? Well, that's easy because each time we're just moving 1, right? 1, and then 1 plus 1 is 2. Plus 1 is 3, plus 1 is 4, and so on. So the length of each space here is 1. But what about this one right here? We're not going by ones. If I look here, I'm going 10, 20, 30, 40, 50, 60, and so on. And then in the negative direction, the same. Negative 10, negative 20, negative 30, negative 40, negative 50, and so on. So in this case, a space, it looks the same, right? As far as the length goes, but if I look at the numbers, this space here is not worth 1. From 0 to the first space is 10. And I'm counting by tens, right? 10, 20, 30, 40, 50, and so on. So in this case, the length of each space is 10, right? 10, 20, 30, and so on. Using that same idea, if I look at this next one, I can see that whether I decrease to the left or increase to the right, I'm skipping by 5s. Look here, -5, -10, -15, -20. Each time it's decreasing by 5. And same thing this way, increasing, it's increasing by 5. 5, 10, 15, 20, 25, and so on. I'm counting by 5s, so the length of each space is 5. Well, how can we use this to answer real-world problems? Consider the following situation. I'm going to show you a video that was taken in this city right here. It's called Duluth, Minnesota. It's in the northern Midwest of our country. So we're way down here, right, in warm Southern California. But I'm going to show you a video from Duluth, Minnesota.
Hurry! Hurry, hurry!
Are you recording?
Yeah!
Did you stop?
So there's a lot of questions you could ask from that video, but the one I want to focus on, there's actually a couple of questions, like what was in that cup, right? What was in there? Or things like, how cold was it in Duluth? Because there was some, or, you know, if there was something in that cup and she threw it up in the air and it looks like it froze or it turned to snow or something, right? How cold do you think it would have to be for something to be that cold? Well, we can answer that question, but we're going to kind of answer it in a roundabout way, and we're going to use the number line. So rather than directly telling you about the temperature in Duluth, we're going to compare it to the temperature in another city. We're going to go south from Duluth down to Atlanta, Georgia. Now, Atlanta is about the same sort of level right here as California, but it can get cold in Atlanta. I know it can snow there. Rarely it does. And let's say that it is 5 degrees in Atlanta, Georgia, which is still not very warm. And we know that there is a 30-degree difference between the temperature in Duluth and Atlanta. We can use this information to determine the temperature in Duluth. If we know what the temperature is in Atlanta, and we know there's a 30-degree difference, we can model that on the number line and calculate the temperature in Duluth. First of all, let's just get this out of the way. Duluth is probably going to be a lot colder than Atlanta. So how do we model this on the number line? Well, this is the number line I gave you because you don't want to usually have to try and use more than 10 spaces in the positive or the negative direction. I also turned it on its side to model a thermometer, right? A thermometer, positive temperatures go up, like the warmer it gets, the higher the thermometer is, and negative numbers go down. So we're going to create our number line the same way. Now, if we look at the temperatures, we know it's 5 degrees in Atlanta, and there's a 30-degree difference. So if I want to model these kind of numbers on the number line, I need to think about how I would set it up. Now, I could go by tens because of the 30-degree difference, but then how would I put 5 degrees on the number line? It would have to go in between two of these lines right here. So I'm going to go by 5s. Then you'll set up your number line the same way, right? Positive numbers, the warmer it gets, the higher it is. So we start at 5, 10, 15, 20, 25, and then going down, -5, -10, and so on. But go by 5s. Next, on here, we want to plot the temperature in Atlanta, Georgia. It's 5 degrees in Atlanta, so we'll put a dot here and label it. And then you have to be careful because this says there is a 30-degree difference between the temperature in Duluth and Atlanta. That does not mean the temperature in Duluth is 30 degrees. It means that there is a difference or a distance of 30 degrees in the temperatures. Now, thinking about Atlanta and thinking about the video you saw of Duluth, you can imagine that it's going to be a reasonable assumption that it's going to be colder in Duluth than in Atlanta. So when we say 30-degree difference, we're not going to go 30 degrees up, we're going to go 30 degrees down. Now remember, each space is worth 5. So when I count my 30 down, I'm not going to go 1, 2, 3, 4, 5. Right? I'd run out of room. I'm going to count by 5s. So 5, 10, 15, 20, 25, 30. That is the difference between Atlanta and Duluth. I start at 5 and I move 30 degrees in the negative direction. And I don't end at 30, but where I end is my temperature in Duluth. Right? 30 degrees difference means travel a distance, in this case in the negative direction, of 30. And we end here at negative 25. So that means that the temperature in Duluth is negative 25 degrees. Let's look at another example. We're going to look at the difference between Casper and Petoskey. Again, Casper is 20 degrees and Petoskey is negative 5 degrees. So I think I'm going to set my number line up by 5s, like so. Then I need to plot both temperatures, right? Because in this case, they're asking what the difference between the temperatures is. We know the temperature in Casper. We know the temperature in Petoskey. We want to figure out the difference, which we can also model on the number line. So we put them both on, right? Petoskey is negative 5 degrees and Casper is 20 degrees. And then we need to count the difference between Petoskey and Casper. Now again, when you count, don't count 1, 2, 3, 4, 5, because each space here is not worth 1. We're skipping by 5s, right? 5, 10, 15, 20, 25, 30, and so on. So each space is worth 5. So it doesn't matter where you start, as long as you start at one city and go to the other. So I'm going to start at Petoskey, and it's at negative 5 degrees, and then I begin to count. 5 degrees, 10 degrees, 15 degrees, 20 degrees, 25 degrees. So there's a 25-degree difference if I count the distance between the temperatures in Petoskey and Casper. And if I'd started at Casper and gone the other way, I would have gotten the same temperature difference. Watch. 5, 10, 15, 20, 25. It doesn't matter. Either way, you will get that the difference between the temperatures is 25 degrees. Finally, you need to write a summary. Your summary should review the definitions of important vocabulary and answer the essential question. Remember that for this lesson, the essential question was, how can we model integers on the number line? You can include important vocabulary definitions like the definition of integers, and you could give examples like how we found the temperature in Duluth, or how we calculated the distance between two temperatures, or the difference between the temperature in two cities like Petoskey and Casper. The summary should be 4 to 5 sentences, and it should not use the words I learned. And by that, what I mean is your summary should not be about how you feel about the lesson. Your summary should be about facts. When you're done, go to Google Classroom, turn in your notes, actually keep your notes, and then go to the Unit 1 Level 1 practice.